Hello and welcome to another Dev Nation Live. We're coming at you live, in my case, from Wake Forest area, or outside of North Carolina, Raleigh, North Carolina. James, where are you at today?
Today, Burr, I'm in Orlando, Florida.
Fantastic. So we're actually both at home. Normally, I'm out traveling about when we do all these live sessions. And so you have a really great topic for us today. I know a lot of people out here who have been watching this session, either watching it live now or watch the recording, have been loving the fat jar. Fat jars seem to be all the rage these days, and which is kind of interesting to me. If you think about it, would you actually put that fat jar on the cover of the magazine? I don't know. So let's talk about fat jars. And so James, take it away.
All right, great. Thanks, Bert. So I'm going to go ahead and share my screen. I got a very minimal amount of slides. I know we're going to try and limit ourselves here to our time, so I don't want to take up too much here. So hopefully you see my screen. Are we good?
Yep, very good.
All right, great. So hello, everyone. My name is James Falkner, as Bert mentioned. I'm a technical marketing manager for JBoss middleware within Red Hat. Today I want to talk to you about fat jars. We're going to look at a couple of different technologies and explain kind of what's going on here with fat jars. So let's just go ahead and dive right in. So you've all probably heard of fat jars if you're here. Dropwizard is a packaging and a framework that started it in around 2011. A fat jar is essentially a jar file, a Java archive file that contains both your application, its dependencies, and all of the things needed to run it with java-jar. So they're very easy to understand. They're easily portable. You can run them very easily, java-jar. You can set up your IDE to run them very easily, and the dependencies that your app requires are resolved at build time, not in production. That's kind of a key tenet of fat jars. Everyone supports, as I mentioned, Dropwizard first. Also, we're going to look at Spring Boot, Wildfly Swarm, as well as Vertex today. Again, everything's in one jar, which means in the world of Linux containers and container orchestration, everything is in one container layer. When you rebuild your jar, when you make a one-line change to your application, add no dependencies, the entire fat jar is rebuilt and restuffed into that layer, Linux container layer, and then pushed out to your production cluster. So you can imagine the complexities that come along with that and the cost of that. So if you look at the relative sizes of a Hello World fat jar with a single 500 kilobyte library, the Joda time library, comparing them between the different technologies, you can see clearly Wildfly Swarm is the winner here. Produces the largest fat jar file, followed by Spring Boot and Dropwizard around 15 megabytes, and then finally the winner here, Vertex, at a very small 7 megabytes. That's actually grown from 4 megabytes about 6 months ago to the latest version. It's grown a bit. So they're adding more features, and as you can imagine, that makes things grow. So when you push that 45 megabyte fat jar file to a new Linux container image layer and then out to your network, you can imagine the cost of transferring that over the network, storing it in a Docker registry, and spinning up nodes and containers within your cluster. The cost starts to go high. This is a Hello World application. If you look at a larger application, maybe a real world application instead of Hello World, they can grow up to around 200 megabytes for the code plus dependencies. So the size of the libraries, the frameworks you're using, whether you're using Wildfly Swarm or Spring Boot or what have you, start to become less important. The more important thing is the overall size of that application as it grows. So that can present issues, as I mentioned. HubSpot experienced this quite a bit. They wrote a nice blog post about a year and a half ago. And you can look at exactly what they're doing. So they had around a 200 or 180 to 200 megabyte fat jar, and they were generating tons and tons of build artifacts per day, rebuilding and redeploying out to production. And they quickly faced that problem, that wall where you are transferring so many files and storing so much on disk that their AWS bill started to creep up and up and up and up and up, and they decided to look for an alternative. So we're going to go through some alternatives today. Also, in the Java EE world, if you're a Java EE developer, you've actually been doing the alternative, which is a thin jar or thin WAR file since the beginning of Java EE. Adam Bien is a proponent of thin WARs deploying to application servers. You don't necessarily need a fat jar to get the same kind of benefits that you've been able to get for a decade or more using Java EE and app servers. So the only issue with that is the traditional Java EE container contains a number of components. First of all, it contains an operating system. It also contains the JDK, the runtime. You also have some negligibly sized build scripts, but then you also have your FatJar plus the app server itself. So in a Linux container image, you can see the problem here, right? Every time you make one line change to your application, at a minimum, you're going to be pushing 209 megabytes with this particular image. Obviously, we've moved further along from this. So going from this to, say, Spring Boot. So with a Spring Boot FatJar and a minimized operating system, namely Alpine Linux in this case, you still have the 100 megabytes of your JDK, but now the application is only 14 megabytes plus the dependencies that it needs. So it's a much more attractive option, especially when you need to make a one-line change. Now you're only pushing 14 megabytes instead of 118 megabytes. So awesome. Wildfly Swarm has a very similar layout here in a Linux container image. We also have a small operating system, small JDK, and then the application sits on top of that. So the point here is that if you're able to split up your application and put boundaries between the different layers and have the layers that change quickly at the top and the layers that don't change very often, like your library dependencies or your application server or whatever runtime you're using, lower in a lower layer, then when you make a change, only the upper layers get changed, and the caching mechanism within Docker or Linux containers takes over and can minimize the amount of change necessary to actually push that updated container out to production. So just a brief level set here on terminology. So we all know what FatJar means. That's everything in order to run the application. The thin variant is where you remove the runtime, the application runtime, whether it's a Java EE app server or Tomcat or Jetty or some other runtime, and only have the application plus its dependencies in the thin layer. Then going down further, we get to the skinny layer. This is where you remove the application dependencies in addition to the application runtime, and you're left with only the things that you literally type into your IDE when you're developing. Very, very small, but again, must be deployed to something that can run it. They don't run on their own. They're not fat jars. Okay, so let's do a demo. So I've got some code prepared here. You can see the URL here to my GitHub repository if you want to check it out later, or you're checking out the recording. So we'll switch over to my IDE here, and I have a number of different projects. So I'm going to demonstrate some of the techniques you can use to make your fat jars lose a bit of weight. So we'll start with Spring Boot. So I have a simple Spring Boot application here. It's got a Spring Boot application main class here. I have a simple property, and then I have a controller, which essentially exposes a RESTful endpoint to this Spring Boot application. So I'll go ahead and build that, and let's take a look at what happens. So Maven clean package. I'll go ahead and build the Spring Boot fat jar, and if I look at what the result is, I can see my Spring Boot fat jar is here, sitting around 14 megabytes. I can actually run that java-jar that, and it will fire up Spring Boot. I'll switch over to another terminal here and hit it with my URL here. That's not the right one, so I'll go ahead and remove that. So it's API/greeting. So this is a sample application I'm using for all of the different runtime, different frameworks here. So that's my Spring Boot fat jar. Pretty simple to understand, about 14 megabytes. So let's move over to Wildfly Swarm. So same kind of deal here, Maven clean package, and build that Wildfly Swarm application. Again, that is also a very simple application, uses JAX-RS to expose a single RESTful endpoint. And if I look at my result here, I can see my fat jar is sitting here. Where is it? Here, 45 megabytes. So I can go ahead and run that. And very similarly to Spring Boot, it'll start up, and I'll be able to hit that with my same URL here, and I get my hello world message. So let's take a look briefly at what that looks like inside the jar file. So I make this a bit bigger. So I'm just going to target that. This one. You can see what Wildfly Swarm did is essentially package the application. The application is actually way up here at the top. Well, it's somewhere up here. Basically, the application's inside of there as well as a Maven repository. Maven has a number of ways of doing dependency resolution. So packaging the dependencies as an internal Maven repository makes a lot of sense because you can then use those libraries to automatically link application dependencies into the application itself. So, and then there's also some bootstrap code in here. But it's essentially an opaque fat jar file. If we look at Spring Boot fat jar file, so let's take a look at that. Targets, zip. Just comparing these. This is the last time we're going to look under the hood here. So here's my Spring Boot fat jar, very similar. It has a number of bootstrap libraries, as well as the libraries for the application itself. There may be some libraries in here I could potentially remove with some Maven magic. Maybe my application doesn't use, I don't know, JPA or something, so I don't need some of the libraries in there. But that's the fat jar Spring application. So, okay, so that's fun. So let's do a couple more here. So let's go to Vertex. The Vertex is interesting. It uses a what we call the Maven Shade plugin. So Maven clean package, and it essentially does the same thing. It takes the dependencies, takes the application itself, packages it into a single jar file, and then you can run it. If we take a look at that one here, jar, they're very similar. Got a bunch of stuff in here. All in this case, it's all kind of in a single flat class path. Thanks to the Maven Shade plugin, all the dependencies are there, and I can go ahead and run that. I won't run that to save some time, but it'll essentially open up a single RESTful endpoint as well. Okay, last one here for fatness, Dropwizard. So Dropwizard was the first one to do fat jars, so I'll go ahead and do that one. That one also uses the Shade plugin to take all the dependencies of the application and inject them into the runnable jar file, which you can see here. Target/star jar. So you can see here's my runnable jar file. I can actually run that one as well with java-jar. So you've probably all done this in the past. I'll open up that one, and then you can go ahead and hit that one, and then you've got your Dropwizard fat jar running. So fat jars are cool, very easy to understand, but they can grow in size as time goes on. So what we want to do is look at some alternatives, and this is the point of this this particular hangout here. So let's start with Spring Boot. So for Spring Boot, there is an experimental plugin in Spring Boot written by one of the founders of Spring Boot called the Spring Boot Thin Launcher. So you can see in my POM file here, I'm using this particular plugin called the Spring Boot Thin Maven plugin. And this is essentially going to do the work of separating the application from its dependencies. So if I go ahead and build this same exact application, go ahead and build that one, and we'll take a look at what it does. I'm here. Okay, so that's done. So let's see what happened. So it actually created this directory under the target directory, under the build directory called thin. So I go into thin root. Here's my application. This is my thin jar file. And then the repository is, again, a Maven repository, very similar to Wildfly Swarm. It creates a separate Maven repository, which you can then package separately in separate Linux container images. So, but without even packaging it, I can simply run it here, and it will find this repository in the local directory and then be able to boot itself up. So now I have my running thin Spring Boot jar, but the magic comes when it's time to package, because we're all using Docker and Linux containers now. So let's go ahead and package that up. So I have a very simple Docker file here. So the Docker file adds this thin repository, this Maven repository, and then my thin jar file into separate layers. Notice they're in two separate lines. So if I go ahead and Docker build JHF Spring latest dot. So let's go ahead and package my application. You'll notice in the process of building, it actually realized that the repository hasn't changed. I haven't actually touched that repository in a couple of months. So it's able to use the cached version of that repository, and only the application is not cached. So if I look at the history, look at the layers in this jar file, I can see, if I look at Spring latest, you can see the topmost layer is what contains my application. It's only 11 kilobytes, much better than the 14 megabytes from a Spring Boot fat jar file. And then you can see the next layer down is the repository, which is around 25 megabytes, but it hasn't been touched, so it was able to reuse that cache. So, which is awesome. So now if I can just run this, Docker expose the port, Spring latest, run. So this will run this in a Docker container, start it up, and then I can hit that as well. and I can see my thin jar is still the same exact message, but coming out of the runnable Docker container that I created with my different layers instead of a single fat jar and a single layer. So that's cool. Let's see what's next. So let's take a look at Wildfly Swarm and what it does. So Wildfly Swarm is an interesting, has an interesting property. Let's see, fat, thin. So Wildfly Swarm, when you build, it actually builds both the fat jar, which is here, as well as the thin war file, which is here. The thin war file only contains the application plus its direct dependency. So if we look at this file, we can see it contains my application here, which is very small, about 2 kilobytes. And then it also contains the direct dependency, which is this time library. So I can do a very similar thing that I did with Spring Boot, and create separate layers for those. But what I wanted to talk about is this application dependency here. So Wildfly Swarm is based on the upstream Wildfly application server. It has a project or functionality in it called JBoss modules. This is for doing class loader isolation and being able to load multiple applications with the same app server in different contexts. So in order to do this, you need to package both your application plus its dependencies as a single war file so that it can put them both on the same class path and they don't conflict, and you're able to use multiple versions of the same library in different applications without having conflict. So with Wildfly Swarm, in order to create this skinny approach to packaging, we want to remove that because this thin war file, while it's 500 megabytes or 500 kilobytes, still not as small as we can get. So, but before I do that, I just want to mention that thin war file can be deployed to any app server. So I'll go ahead and start up Wildfly here. I have Wildfly running on my local machine here, and I'm going to go ahead and copy this, the thin war file, just to demonstrate the thinness. Here, I'll copy this to the standalone deployments directory of Wildfly, and you'll see I'll go ahead and deploy that. And it's running on port 9000, so if I hit it on port 9000, I should get my the EE/Wildfly Thin War running in a full-fledged app server, in this case Wildfly, running locally on my machine here. So that's the thinness of Wildfly Swarm. So let's do one more thin, and then we'll move on to skinny, and then we'll be done here. So let's go to Vertex. So Vertex has a concept called verticals, and these are kind of independently deployable pieces of business logic that you can deploy out to a Vertex runtime. So in this case, I'll do Maven clean package to build the thin version of the Vertex application. Take a look at what happened there. Target star, here's my thin vertical, only 624K, because it includes that same time library that I mentioned earlier. So in order to build this as a separate layer in Docker, we use another Docker file. So just take a look at this real quick. It's lines long here. I'm essentially using a pre-built Vertex 3 runtime to supply the runtime, and then simply adding my vertical to the vertical's home directory, and then I can run that. So if I want to build that here, Docker build dash tag JHF Vertex latest Docker build, and build my thin Vertex application, and you can see Docker history. Latest. See, now my top layer here is my very thin Vertex vertical, about 630K, and then the rest of it is Vertex itself, which is represented in these other files here. So I can go ahead and run that. I'll go ahead and hit that real quick from my same. And here's my Vertex thin vertical running in my Docker container here. So I was able to package that. So then when I make a one-line change, say for example, I'll go ahead and make a one-line change, Vertex thin in my source directory. Here's my simple app, hello, update. And build that, clean package. and then rebuild the Docker image. And you can see it was able to use the cache for everything except for the small vertical here. And then I can run that again and it would do exactly the same thing. So when I make a one-line change, I no longer touch my 6 megabyte fat jar. Now I'm touching my 500 kilobyte thin jar. Okay, so the last bit I want to talk about is Wildfly Swarm again. So we'll go back to Wildfly Swarm, and you remember that JOTA time library, which is about 500 kilobytes. Not a big deal for 500K, but as your application becomes a real-world application, you can grow, like HubSpot found, up to around 200 megabytes. So it's important to separate those out. With Wildfly Swarm and its inheritance from Wildfly, the way you do that is through the JBoss module system and what we call fractions. So Wildfly Swarm has this concept of fractions where it's kind of a packaging mechanism where you can package up functionality that only you need and then include that in your build and make your applications much smaller and leaner and less code and less cruft. So in order to do that, you need to build this JOTA time library as a fraction. So I have a project here which will do exactly that. So I'll Maven clean package and then install it, which will install it to my local Maven repository. I can then include that fraction in my WAR file, or in my my built-in application by using a declaration. So if I look at the POM file for this final project here, you can see in here I'm actually including a dependency on my fraction, as opposed to including a direct dependency on the application itself. So I'll go ahead and build that. Build my skinny jar file, and then I'll be able to deploy that. So what happened when I built that is it created what we call a hollow application server. It's essentially the runtime of Wildfly and Wildfly Swarm, but without the application itself. So I can java-jar that, but that doesn't make much sense because the application isn't there. So I need to mention the application I want to deploy, which is this super thin application, 249 kilobytes, or 249 bytes, so about 2K. So if I can run that, it essentially will act much like a traditional Java EE app server where you can deploy applications into it. I have my application up and running now. I can hit it and I see my skinny jar file. What's more interesting is I have two applications that I want to run. So I have another application that I built. So I'll go to my skinny2 target skinny weight2.war. So now I can run two applications with the same exact runtime without any modification whatsoever. And it's kind of interesting. We're kind of going back to where you're deploying multiple applications to a single app server. In this case, we're doing somewhat similar, but the difference is we're able to package those dependencies of those two applications separately, not only keep them in separate Docker container layers, but also check them into our repository, artifact repository, whether it's Nexus or JFrog or something like that. So now I have my two applications. I have my original application and I have my other application sitting on a separate web context here. So I have these two applications running with the same runtime. So then I can, essentially, this allows companies to standardize on the set of dependencies that their application developers are able to use. A lot of times we talk about fat jars being very simple for the developer, and that's absolutely true, but it also gives you great power, and with great power comes great responsibility, and so companies generally try to limit that responsibility to avoid issues in production. So that's the skinny Docker, or sorry, skinny application for Wildfly Swarm. One last thing, if I wanted to package this as a Docker image, I have a Docker file here, I believe. So let's take a look at this Docker file. So this Docker file does exactly the same thing. It packages the hollow jar of Wildfly Swarm into one layer, and then it packages the skinny application into another. So I can do a Docker build that. Docker build -t swarm latest. We'll go ahead and package that application up. If I then make a single line change again, very similar to what I did earlier, so I'll hit hello update, if I can spell, repackage that. Now when I rebuild my Linux container image, everything should be cached, and the only thing will be touched will be that that 2 kilobyte image layer at the end, which is very small. So now a one-line change means 2 kilobytes of change, not 45 megabytes of change. So very similar to Spring Boot. Okay, so again, all this code is on Docker, on GitHub if you want to try these things out if you're watching the replay. I know I went a bit fast, but hopefully you get the idea. So let's go back. I got a couple more slides here. So kind of a summary slide. So the end result here is that there are various mechanisms and techniques you can use to take a fat jar that's growing out of above the size that you really want, and break that up into separate layers so that it's much easier to deploy those container images out to your production clusters. So obviously with the fat jar approach, everybody supports that. That's kind of clear. The thin jar, where you have thin jar or thin war, where you have your application separated from the runtime, are possible to do with all of the technologies. In the Spring Boot case, we have the Spring Boot thin launcher. Wildfly Swarm has the innate concept of thinness via Java EE and the traditional war file deployment mechanism. Vertex it's possible to do that via Maven, which I showed. Dropwizard, you can also do thin using Dropwizard. I didn't have time to attempt that, but I did find a blog post here. There's a link that you can visit later on. I think I might have it in the slides here, of a community member who was able to do that with Vertex. And then for skinny hollow support, where you have the ultimate kind of smallest possible unit of deployment, or smallest possible unit of your container layer, Spring Boot has there's a mechanism written by another community member called a Docker prep plugin, which will actually split your application, its dependencies, and the runtime into 3 separate layers and give you a lot of control over that. So you can do it with Spring Boot via that. Wildfly Swarm, as we mentioned, has the concept of fractions, where you can extract all of the dependencies of your app into separate fractions and then be able to reuse those in your corporate developer pipeline. Vertex and Dropwizard, I believe you can do this as well. I haven't tried it, but there's a project out there called capsule.io, which is, from what I've seen in the last few days, a kind of a Swiss Army knife of Java or JVM applications, and you can do a whole lot of stuff with that. So you're able to, I believe you're able to split up the application into separate layers as well. I haven't had time to play with that, but if you're interested, or if you know of that, or if you're familiar with this project and have some information about it, feel free to share it with me. I'd love to see it and see what you can do with Vertex and Dropwizard, and probably any other JVM technology. Okay, so last slide here, kind of a summary slide. So fat jars is definitely not a anti-fat jar approach or anti-fat jar presentation here. They work really well in many cases, and they're super developer friendly. As they start to grow and grow, which they inevitably will, if they exceed a certain boundary that you have in mind, take a look at some of the technologies for doing thin deployments and separating them into separate Linux container images. It makes a lot of sense, especially when you're at production at scale, to be able to separate those out and minimize the change that goes out whenever you make a change. And then Skinny Hollow is kind of a super set of that. It's highly efficient. It really separates everything out, and you can have a lot of control over the container layers that you're building, and putting the most frequently changing layers at the top with your dependencies below. But of course, it adds an initial complexity to kind of set that up and get your pipelines up and running consistently, along with your unit tests and packaging. Okay, so I think I'm done, Burr. Questions?
Well, that was totally awesome. We do have some questions. If you would, throw up the URL to the GitHub while we're taking some questions also.
Sure.
One question on Vertex apps around making thin Vertex apps. Have you seen anyone do it with Gradle? I know Gradle's supported by default, but I don't know about that specific thinning aspect.
Yeah, so I have not done it with Gradle personally. Generally I'm a Maven guy, but the Capsule project has support for Gradle, so I'm imagine you could probably do it through that. But again, I don't use Gradle, and I haven't seen anyone in the wild doing that, but I'm pretty sure it's possible.
Okay, and my guess is too.
Yeah, ultimately all of these applications are JVM applications in a jar file, so you can use all kinds of Swiss Army knives to split them up. The question is, how supportable is it, and how consistent is it, and how bug-free is it?
Another great question too is about the S2I Java builder, specifically
Yep.
on OpenShift. Are you aware of any roadmaps to specifically address that point?
I am not aware of roadmap. You talking about for building like thin applications?
Right, right. I know by default they assume an app server target or a fat jar target, but I don't know about kind of the in-betweens there.
I I would be surprised if I don't think that technology belongs in that particular S2I image, because it's basically a Java generic JVM runner, and the way you split up applications are different depending on which technology you're using, Swarm or Spring Boot. So I don't know of any particular roadmap for the official S2I image that comes from OpenJDK.
Okay, and I've not heard of anything either.
Yeah.
It is a good point. There was another question around how big do these jars get, and it occurred to me that back when we were in the old days of ears, I regularly saw multi-gigabyte ears.
Yes,
they
absolutely.
Got big fast.
They get big really fast.
Yeah.
My Hello World is tiny, but yeah. So as soon as you include database drivers and clustering, all kinds of stuff, it grows really fast for a real world application.
And I think one thing people tend to forget about when they build these fat jars is, yes, putting them in a single Docker container and running that single Docker image and putting it into a single Docker daemon, that's easy. It's not that bad. But if you have a cluster of, let's say, 25 nodes,
exactly,
that actually has to get to 25 nodes, and you're transferring all those bytes across the network to get out there.
Yep, absolutely. And you're storing them in Docker registries, and the layers will add up and up and up as you add more, essentially duplicate layers in images that have a very small amount of change, but it's a completely opaque to Docker.
Oh, and I've also run a disk space before too because of that.
Yep,
literally,
that can happen as well.
Yeah, which is just bad because you can't figure out what went wrong in that scenario. So in a Kubernetes or OpenShift architecture, going thin is definitely a win.
Absolutely.
Okay. Well, I think that's all the time we have for today. James, awesome stuff on the demonstration. This was really a fun session. I really enjoyed it. Hopefully the folks out there watching live and watching the replay enjoyed it. Make sure to follow James on Twitter. Keep coming back to developers.reddit.com/devnationlive. We are now planning for the 2018 version of this series. We got a lot of new good content coming in the next year, but enjoy your holidays because we'll be taking the rest of the year off. James, thank you.
Thank you, Burr. Thanks for having me.